intro to matrices. Matrices are very useful in the real world. Are you going to go to Walmart and draw out a matrix? No. It's used a lot in like computer programming, behind the scenes, all kinds of stuff like that. But we're going to learn the basics of matrices. A matrix is an array of numbers. It's an array of numbers, just numbers that look like form a box, basically. A matrix is divided into rows and columns. Which way do rows go? Left to right. Columns? Up and down. The dimensions, or you might see the word order, of a matrix depends on the number of rows and the number of columns in the matrix. So when I'm talking about the dimensions, you might have this. That would be a 2 by 5 matrix. 2 by 5, which means 2 rows, 5 columns. So if you're looking at matrix A, over here on the side, this is matrix A. How many rows does it have? 2 rows. How many columns? 3. So row, row, column, column, column. So 2 rows, 3 columns. It's a 2 by 3. Each number in the matrix is called an element. So for example, matrix A has 6 elements. There are 6 numbers in there. You can take the dimensions and multiply them to get the number of elements. A 2 by 3 has 6 elements. What does a 7 by 5 have? 35 elements. Good. Elements have a specific name, so that I can say, like we can be looking at a huge matrix and I could pinpoint one of those elements and you know exactly which one I'm talking about without me actually having to point to it. So those names usually come from a lowercase letter. That lowercase letter is going to match the matrix name has an uppercase letter. So matrix A, each element would have a lowercase a plus a little number in the bottom right corner we call a subscript. And that subscript tells us exactly what element we're talking about. So I've given you some examples here to show where those names come from. This is not A11, it's A11, which means this is the element in matrix A that is in row 1, column 1. This is the element in matrix A that is in row 1, column 2. All right, and so that way if I had if I had 26 matrices up on the board and I could say find element C15, you could get it real quick. You know to look at matrix C, first column, or first row, 5th column. Alright, so if we're asked to find B, not B12, B1, 2, we're looking in row 1, column 2 of matrix B. So in matrix B, row 1 is there, column 2 is there. What good. I want you to work questions 1, 2, and 3. Ask about the dimensions. So I've given you 3 matrices. I want you to write down the dimensions, like a 2 by 3. And I'm going to call on some of you to give me the answer. And matrix B, Jared, what'd you get for question 1? 2 by 2 is correct. Jace, question 2.
1 by 2.
A what?
1 by 2.
Close.
2 by 1.
No.
1 by 3.
1 by 3.
Oh,
Matrix C is a 1 by 3. So we have 1 row, 3 columns. Even though it's just 1 element in each column, there's 3.
Oh, yeah.
3 columns. You should have counted. Alright, question number 3, Adriana.
3 by 1.
3 by 1 is correct. Alright, the next 6 is asking about the specific elements on the matrix. So work on those.
That was fun.
Alright, number 4, Kristen.
I got 7.
You are correct. Number 5, Colin. Yep. Number 6, Jay.
-3.
Perfect. Number 7, Janae. 11. Number 8, Michael. -9. And number 9, Aiden.
0.
Correct. Very good. Alright. Few more vocab. These first 4 are like super obvious just by the name of them. A square matrix is a matrix that has the same number of rows and columns. It's like a 2 by 2, a 3 by 3. So for example, that's a square matrix.
So why do we put numbers? Why can't we just list them?
List what? Because you can do different operations with them when they're in matrix form. Calculator does stuff with them in matrix form. A zero matrix is a matrix in which all elements are, what do you think? 0. It doesn't matter what the dimensions are. That would be a 0 matrix. A row matrix has exactly 1 row. That's a row matrix. A column matrix has exactly,
One column.
wow,
That was tough.
That one's stuck.
Yeah, that's.
Alright, the last one is one that is not as obvious. An identity matrix is a square matrix, so it has to be a square matrix that has ones, positive ones, in the diagonal from the top left to the bottom right. So in your matrix, the ones go in this diagonal, top left to bottom right, positive ones. And then zeros are everywhere else.
Is this a common thing?
Well, we'll actually see this later on. So we'll talk about inverses. The inverse of 2 is 1/2. What happens when you multiply 2 by 1/2? Turns into 1. When you multiply a matrix by its inverse, you get this. So it doesn't turn into ones, it turns into the identity matrix. So like, we will practice multiplying matrices, which is a complicated process actually. But if you take a matrix and you multiply it by its inverse, you get this. And that's it.